we are going to be simplifying rational expressions. And recall is that we can say, what's rational mean? Well, rational could be interpreted as fractional expressions. Doesn't have to, but that is a quick way to remember what it means. You do not have to write this down. We already did this. But what was the idea behind it? I said, well, if we can find a common factor with my numerator denominator, then I can reduce, because 8 divided by 8 is 1, and I'm left with my simplified form 1/3. So to simplify means reduce all common factors in these contexts. Reduce all common factors. So now we're going to take it to the next level. We are going to look at not simply monomials, but binomials, etc. So a monomial, remember, is simply terms like this: 3x squared, or simply 4. Those are monomials. But now we're going to look at other things like binomials and trinomials. And a binomial, of course, usually is in parentheses, like an x minus 2, etc. All right. The act of simplifying fractions applies to any type of expression. Monomials, trinomials, binomials, as long as every element is exactly the same. So let's actually start with number 14. To reduce on this one. We do not reduce the 2x's. Do not reduce the 1's. If you do that, you should be punched in the neck multiple times. What we do reduce is the 2x minus 1 and the 2x minus 1. All of it, the entire binomial, is one expression.
Why is it minus 1?
Plus 1, excuse me. Now, the numerator reduces to 1, so my final simplified form is 1/8.
So you put a 1, not a 0?
Correct. That's why I avoid saying things like canceling out, but I say reduce, because these fractions reduce to 1. Fractions will only reduce to 0 if the numerator alone is 0. Well, on number 13, the numerator is already factored. That's one of our biggest goals, is to factor things. And the denominator, I'm looking for a common factor that can reduce. Now that 5 times 5 is shown, I see I can reduce by 5s to become 1 there. And notice the numerator becomes x minus 2, and I do not need parentheses anymore. All divided by 5. On number 15, beware of this. It's tempting to do just this. Oh, look, I can reduce by 7 and I'm done. And the answer is no, because if you're going to reduce the top by 7, you have to reduce the bottom by 7. Everything. You have to reduce everything by 7. So that's one possible way of doing this. I'm going to show it in terms of factoring first. So I'll show factoring first and then show you that you can just reduce it slightly faster. The denominator here, what can I factor out? Notice there's a 7 I can pull out, an x and a square, which will give me 1 minus 3x. How do I know that's right? Because if I redistribute, 7x squared times 1 is 7x squared. 7x squared times negative 3x is negative 21x cubed. The numerator here, I can factor out a 7 times 2 times x. Now notice what reduces. A pair of 7s drop out. 7 divided by 7 is 1. A pair of x's drop out. And I'm left with a 2 in the numerator. And I'm left with the x times 1 minus 3x in the denominator. Like that. Okay. Now, alternatively, if I chose not to factor first, I could have done another method from the beginning. If I wanted to just start here, and I say, oh, look, there's a 7 everywhere. You're right. Divide this by 7 to get a 2. Divide this by 7 to get a 1. Divide this by 7 here to get a 3. So each term gets divided by 7. What else? This divides by x to give me a 1. This divides by x with an exponent of 1. This divides by x to give me an exponent of 2. So notice what's left. In the numerator, I'm left with a 2. In the denominator, I'm left with an x minus a 3x squared. And that's the exact same answers down here, except this one's factored. That's it. Factor out the x. Same answer. Both of them are acceptable for final answers. There actually isn't a law that says one is simplified beyond the other one. On number 16, we can drop out an x from here, and an x from here, and I'm done. 5 over x plus 3. Alternatively, it looks like this. 5 times x over x times x plus 3. Now that everything's factored, I can divide the x divided by x as 1. When we're looking at number 17, we wonder if the commutative property here works. Well, let's try an example real quick. Is 3 minus 4 the same as 4 minus 3?
No.
Oh, no, they're not, because this gives me a negative 1 and this gives me a positive 1. They're almost the same. How are they different?
They're opposite.
One is the opposite of the other. So what if I had put this? What if I put a negative outside here? Negative outside here. Are they the same now? Yes, because double negative here becomes positive equals 1. So what can we say about subtraction? Does subtraction commute? No. But if I did commute it, what do I have to put in the front? A negative. So commuting subtraction means I need to take the opposite of the commute. Okay, so now let's apply this, the general rule. If we commute a subtraction, we have to factor out a negative. So that means the numerator here can stay the same, but the denominator, if I commute, I have to put a negative outside it. And what's my mistake? I didn't commute. If I commute them to get x minus 4, I have to put a negative outside. Now what reduces? Remember, the x's don't reduce, the negative 4's don't reduce, the x minus 4 reduces. They both reduce to 1 with a negative hanging out in the front. Negative 1 is what I get.
What makes them negative?
Another skill that we need before we get to the next problem is to recall this. For shortcuts, if we have a difference of squares, remember what that means? That's a squared minus b squared.
Yep.
That's the same thing as saying a minus b times a plus b. All right, so when we look at number 18, we're going to use two things at least here. On the top, notice that I can pull out a GCF, a common factor of 5. So the numerator can factor to be 5 times x minus 5. Down below, I recognize that as a difference of squares. A difference of squares. So what's it factor to? 3 minus x and 3 plus x. Where's my mistake earlier? When I GCF out of 5, what should it be? Divide this by 5, so that should be a 3.
Okay, so that's
3 there. So now, just to clean it up a little bit, the numerator is x minus 3 times 5. And if I were to commute this to be x minus 3, I need to put a negative in the front. Now, this one here is going to stay the same. Or I could commute it with no change, because 3 plus x is the same as x plus 3. Now, the x minus 3's reduce to 1. I'm left with a 5 in the numerator, a 3 plus x in the denominator, and a negative somewhere there. So the top here is already simplified. I don't need to factor it at all. And the denominator, I can do a difference of squares. Difference of squares. Okay, so The top stays the same, 8 minus m. The denominator becomes this, m minus 8 times m plus 8. And what do we recognize? Are these exactly the same? No, they're commuted. So if I commute this, what has to come out? A negative. So those can drop out if I put a negative outside. Now I end up with negative 1 in the numerator and m plus 8 in the denominator. If you need to see that other step, I did negative m minus 8 with a parenthesis there. Then I have an m minus 8 and an m plus 8.
Does it matter which one you put the negative on?
Does it matter which one I put the negative on, like opposed to this one here? Oh, like which pair?
Yeah.
Correct. I could have done downstairs, and because dividing by a negative or having a negative divided by a positive will give you both a negative. So what skills am I going to need here on number 21? Well, notice here that I can snowflake this one and GCF this one. Always test for GCF. Look, there's no common factor in these three terms. This one doesn't even have a coefficient, and this 4 doesn't have an x. So there's no GCF here. But since it's a quadratic, I'm going to try snowflake, see if it works. Downstairs here, I see that I have a 3 that I can factor out of both terms. So, in fact, I can factor the denominator fairly quick. I get 3 times x plus 4. Great, I GCF that one. Now, let me factor the numerator. So I'm going to put a positive 4 on the top, positive 5 down below, 1x on the wings.
How did you get 3x plus 4?
My factors of 4 that sum to 5,
X plus
1 and 4. So that means x plus 4 and x plus 1. So what are the factors that now reduce in my rational expression?
X plus 4.
X plus 4's drop out. Not the x's, not the 4's, but the x plus 4's. So my final result is x plus 1 over 3. No parentheses needed.
Nothing.
Let's take a gander here.
Snowflake
monomials.com.
I'm going to attack, kill, destroy this one. First, though, I'm going to do my negative rule down below. If I put the x squared in the front, move things around, in other words, I'm changing every sign. So I factor out a negative. Okay, now let's snowflake. If I snowflake the numerator, I'm going to put negative 6 and a positive 1 and x is on the wings. And then I find out that it's 3 and negative 2. So x plus 3 and x minus 2. That's the numerator. The denominator still has a negative out in the front, so I'll keep that there. And when I snowflake that one, I put a positive 2 down below, negative 8 upstairs, and an x on the wings. And I find out that it's a 4 and a negative 2. So x plus 4 and an x minus 2. So what reduces here? X minus 2's. So x plus 3 in the numerator. I'm going to put a negative outside and an x plus 4 in the denominator. Like so.
You lost me